I'm here to talk about something called factory in a can. Now, you might think I mean this Coke can in my hand. I'll put the can down later and drink it. All right. Now, when I say factory in a can, what I mean is a factory that can fit or be brought onto site with all the machinery inside that's needed to assemble houses for humanitarian purposes. So literally, we're talking about a can and a factory, and the factory being inside the can, and we've got the shipping container. So you can see a picture of what I mean up on the screen. So the factory contains, or the shipping container contains the factory, and this shipping container can be brought anywhere. It can be shipped to the Antarctic, it can be helicoptered to the top of a mountain, it can even be trucked to a remote village. And once it gets there, you can have local people. Local people can work with the inventors of the factory in a can, and they can assemble the steel sections together and make them into frames and then make them into houses. So what you've got is you've got a can, or you've got a factory, you row the steel sections through it, and then out comes the frames, which are just perfect and just ready. So, temporary frame for shelter after a natural disaster, and people on site able to assist with you doing it. Now, I'm fortunate enough to be a professor of civil engineering at the University of Waikato in Hamilton, New Zealand. My engineering colleagues, I think, do wonderful and intellectual things, such as they can develop computer vision systems that can control a robot and allow that robot to pick the kiwi fruit straight off the vine. And for me, you could say what I do is I crush steel, okay? So I crush cans or something like that. Now, the steel that we're talking about in factory in a can, you find it in everyday items. You find it in filing cabinets, you look at your car, that's cold form steel, and then you look at storage racking systems. So it's already part of our everyday life. And it's not transported as a long beam, but it's transported as a coil. Think of a giant roll of steel, about 1 mile long. So that roll of steel is 1 mile long. Just imagine what you can do with 1 mile long worth of sections. So another way to think of it might be as your aluminium foil that you might have in your kitchen, just a lot longer and a lot stronger. So cold formed steel, it's called cold formed because the robots or the machines, they turn it into these steel sections at room temperature. So at the University of Waikato, we've got a nice research group, about 30 PhD students, and we specialize in cold form steel, and we also look at other building materials, all linked towards affordability. And we use the latest generation of technology, Industry 4, for our work. And as I said at the start, I crush steel, and by crushing steel, I actually mean we've got a laboratory, and we can test the steel sections under compression, we can test the steel sections under bending, and we can test the steel sections under shear. And we also test full building systems. So I've burned down 2 steel buildings just to see how they behave in fire. And we've also done seismic and earthquake tests on these steel buildings. So just give you a story. 20 years ago, I was working in London, and it was just me in an office, and there were a lot of Kiwis engineers in this office, and they were absolutely ingenious, and they could do lots of remarkable things. So they were looking at the use of cold form steel for social housing. So that was new to me then, and it's maybe still a bit new now, but there's certainly a lot of potential with this. So this was the first time I'd come across Kiwi ingenuity and the application of cold-formed steel for housing, and it led me to move eventually to New Zealand. And we have a lot of students here, very ingenious students, all looking at this form of technology. So I do find Kiwis to be very practical people. For low-cost solutions, they can come up with brilliant problems. Brilliant solutions. Rocket Lab, a Kiwi company that literally launches rockets into space. And zero accounting, it's used all over the globe today. It's almost everywhere. So, coming back to this Coke can that I've left on the floor, I'm not sponsored by Coke, by the way, but I do drink, and when I was younger, I drank a lot of it, a lot more than I drink now. One day, I walked into my lecture theatre. It was the last lecture, and I was greeted with the very pleasant sight of 200 or over 200 cans on the desk. That basically meant that the students each had decided to buy me a can of Coke, which I thought was absolutely fantastic. So they must have noticed that I was drinking 5 at every lecture, and of course I will enjoy this one that we've got down here, but later on. Now, Coke can is not steel, of course, it's aluminium, but like steel, it can be recycled almost indefinitely, or it's infinitely recyclable. So the can comes from a factory. I've discussed the factory already. Modern factories, like Industry 4 factories, they can use all the latest modern technologies, but you can't bring such a factory onto site, can you? Whereas I'm saying, with the factory in a can that I've sort of introduced, you can bring that factory right onto site to the exact place where communities might need it straight after a natural disaster. So I think factory in a can could become a game changer because it's small and portable. So here's a true story. So you can see in the background the factory in the can, so it's not in my imagination. This factory actually exists, and you can see the Red Cross. And you can see this is Fiji. So ingenious Kiwis have sent a factory in a can with the Red Cross just to help out for humanitarian well-being. And 3 Kiwis, factory in a can, and 15 local people were able to reassemble a school and enable some people or some children to be able to be taught in the school soon after Hurricane Winston or Cyclone Winston had hit Fiji, devastating communities, houses, and schools. So it just took a week, and the school was restored. Local labor was used, and I personally would like to see these factory in a can and cold-formed steel used a lot more, not just for disaster relief or for humanitarian purposes, although I can see it's got a lot of potential. You could ship up 10 of them, for example, with the Navy, wherever there's been a natural disaster, but even closer to home, they could be useful. For example, there was Cyclone Gabrielle, and after that, there were a lot of families who were having to live in their cars, and a factory in a can could really have helped out. Also, the Christchurch earthquakes and all these natural disasters that now are happening, I can really see a future where factory in a can can be very, very helpful. So let me leave you with this last question. If a metal Coke can and a steel car can be mass-produced in an Industry 4 factory and produced every single day, why not a house? And if that factory in a can be brought onto site anywhere, what are we waiting for? I'll now enjoy my Coke.